Hey guys, welcome back to Weld.com for episode 2 of Welding Symbols. So today we're going to do a quick recap of what we covered in episode 1 regarding fillet welds. We're going to add a couple supplementary symbols to those so that you guys understand what they are and their placement on the welding symbol. We're also going to get into groove welds today. But first, I went ahead and brought in my little quick reference guide. Cameraman's going to put a link in the description for you. It's a great reference guide for if you don't read welding symbols every day, it's pretty easy to forget. So it's a great little reference guide, really handy. Throw it in your gang box, toolbox, whatever. References out all the different types of welding symbols, placement, sizes, everything. So I mean, pick one of these up. They're great to have. All right, so let's go back to the board and we'll do a quick recap on the fillet welds. All right, quick recap. Last time we discussed arrow side, other side, different sides of a weldment. In this case, it's going to be a fillet weld on a T-joint. So we have arrow side 1/4 inch fillet weld, and then other side 3/8 fillet weld. Okay. One additional thing we can do is if we have unequal leg lengths. Okay, this isn't something that I've ever come across myself, but if you get in a situation where the engineer specs out for unequal leg lengths, this is what that symbol would look like. It's going to be the same thing. Arrow side or other side, doesn't matter. In this case, we're just going to go with the arrow side. And let's say they want a 1/4 inch height here, and then 3/8 this way. So that is going to be written, same fillet weld symbol, but it's going to say 1/4 inch by 3/8. And that tells me that this vertical leg here is going to be a 1/4 inch tall, whereas my horizontal leg is going to be 3/8. Like I said, very uncommon, but if you get into that situation where it looks like you got a math problem brewing up here in the corner, that's exactly what that means, is unequal leg lengths. And basically all you're going to have to do on that is just adjust your torch or your electrode angle up a little bit higher to deposit more filler metal on the horizontal piece than you do on the vertical. All right, so that pretty much covers the majority of what we discussed in episode 1. Let's go ahead and we're going to erase this. We're going to get into some supplementary symbols using fillet welds, and then we'll dive into the grooves. Okay, so what we have here, I just drew a box column or a box tube, square tube, and a base plate. Okay, very simple, very common connection. We'll talk about a little bit about blueprints real quick. So this dotted line is your hidden line. That tells me that there's something on the inside that I can't see, and that's just the other edge of that square tube. This right here is a long break. That tells me that this column or post or whatever it's going to be is much longer, but for the sake of space on the paper, they just put a long break on there because everything is going to be typical or symmetrical, the full length of it. So let's get back into welding symbols. Square tube, we're going to go ahead, we'll put a 3/8 weld on here. And now here's your first supplementary symbol. This circle right here. This circle tells me to weld all the way around. So what's that going to look like? There's my square tube again, sitting on top of the base plate, and I'm going to weld all the way around. Now the weld all the way around symbol should never be on anything like a T-joint, because you technically can't weld all the way around because you can't put a fillet weld on the ends. Okay, so that's why they don't do that. They'll tell you to fillet weld on one side, fillet weld on the other, if you need weld on both sides. So this is the weld all the way around symbol. Now if I go like this and put a little flag up here, this tells me that this weld is going to take place somewhere other than the initial point of construction. So let's say that the square tube is cut to measure and punched in the shop, but they're going to take all this stuff out of the field and they're going to weld it in place. So what they would do is most likely mount this to the concrete, set it in place, and weld that out in the field. Okay, so that covers your weld all the way around symbol and your field weld symbol. Okay, and then we're just going to have a 3/8 weld that's going to go 360 degrees around there. So those are two supplementary symbols. All right, so now that we've covered the supplementary symbols, let's go ahead and move into groove welds. Okay, so let's go ahead and talk about the different types of grooves that we can have when we do these. So we have a square groove, okay, scarf, V, a bevel, usually a single bevel, U, J, a flare V, and a flare bevel. And our supplementary symbols are weld all the way around, which we just discussed, field weld symbol, meaning it's going to take place in another point other than its initial point of construction, melt-through symbol, you can think of this as your weld reinforcement or on the back side of the root. Consumable insert, I don't know if you guys have ever had to deal with those. It's actually an insert that keeps the spacing, so it gets consumed during the welding process. Backing or rectangular bar, so you have a spacer here as well, and then the backing, flush or flat. So these are all of our contours. These are the different type of contours or the shapes that our welds can have. You have flat, convex, and concave, and we'll get into this a little bit further later on in this episode, talking about how we're going to make these profiles, how we're going to reshape these if it's not done during the welding process, because there's a couple different options that are available, and it's going to all depend on what is spec'd out by the engineer. So let's go ahead and we'll just start off with a regular square groove butt joint. Just two pieces pushed tight together. And our welding symbol for this is just going to be this square groove right here. We're going to add a melt-through symbol on here. Okay, and the melt-through symbol, you'll notice it's completely filled in. Okay, if we get into back or backing, this is going to be hollow. You're just going to have that little dome in there. We'll talk about that more later. So this weld, let's say what it should have here to the right-hand side of this, this melt-through symbol is a number. So in this case, let's go with 1/16. That means that when I weld this piece in here, I need to have 1/16 of an inch below here. Okay, and that's just a typical square groove joint. With 1/16 melt through, you can have 1/8 inch melt through. It's all going to depend on what the engineer has spec'd out for you. I'm going to skip the scarf because it's very uncommon. I've never used that. I've never known anybody to use that. We'll skip over that one. We'll go to a more common joint configuration, which is the V. So the first thing we're going to do is we're going to draw out our two pieces. We'll put the welding symbol in there, and then we'll go ahead and talk about how we're going to prep this material. Okay, we put our V in here. So what that's going to tell me is this V is on the arrow side, so it's up here. Okay, so we'll go ahead and we will remove this material here. But how much are we going to remove? Is there going to be a root gap in here? That's information we need to know. Okay, so here's another handy little chart. This welding symbols. You can actually get this from our Weld.com website. It's free to download. You can print it off 8.5 by 11, 24 by 36, whatever size. It's good to hang in the shop. And it's just a quick reference guide of where all this information should be. So if we look right up here, okay, we have root opening, angle of our groove or groove angle, and then the finish or the contour. So let's say we're going to have a 1/16 opening. Okay, that's going to go right in here inside the welding symbol. And let's say it's pretty common. Let's go with a 60-degree angle. Okay, that means I need to bevel each plate at 30 degrees, so I have a 60-degree included angle. And then we'll go ahead and add some melt through on here because we're talking about that. Remember, this gets filled in. And what is that weld going to look like? Well, I don't have any weld lengths or depths or penetration, right? It doesn't tell me how far to prep the joint. So as the welder, I'm going to assume that the joint preparation takes place throughout the whole piece. Okay, so let's say that this is a 1-inch piece. 1-inch thick material. So we have our 30-degree bevel on each plate for a 60-degree included angle. We'll go ahead and put a 1/16 root gap in here. So when we put that weld in there, we're going to fill that up. Remember, flush to 1/8 of an inch. We're going to poke down 1/16 down here of our melt through. Okay, and that's where that symbol would be. So standard square groove, single V bevel. Okay, and we just build on it from here. All right, so next up, let's talk about our single bevel groove. Again, we're going to have our two pieces. Welding symbol is going to give us some information here. Remember that vertical leg is always going to be on the left-hand side. It should never be opposite. Joint preparation is taking on the arrow side. And this arrow, it's just telling me, hey, one of these plates have to get a bevel on them. It's not significant. This instance, I'm going to show you in an instance where it is. Okay, so I'm just going to pick a side. Left or right, doesn't matter. We'll go ahead and we'll put an 1/8 inch root opening in here. Let's call that 1/8. and then we'll do a 30-degree bevel on this single piece. That means that from here to here is 30 degrees. And we'll go ahead and we'll run 1/8 inch melt through. Called melt through here, but essentially it's just weld reinforcement. So that weld's going to look something like this. We're going to be flush to 1/8 inch up here, depending on the material thickness, and then we're going to have about 1/8 inch sticking out down here. But what if there is side significance? Okay, what if it tells me exactly how much of that bevel to prep, right? Let's go ahead and talk about that. So here I have two pieces. Let's say that the engineer is telling me specifically, you need to bevel this piece over here. This side right here is the side that's going to receive the joint preparation. So how is he going to tell me that, right? I have to put a break in my arrow line. Okay, so because I have this break here, that means this is the side that the joint preparation is actually going to occur. Here's my single V again, so that tells me that I need to open this side up because now, because of this arrow, this break in the arrow, I have side significance. Okay, if I wanted to break this side over here, the arrow would just break back the other way. Okay, so see how the arrow breaks back to this piece right here? Now this is the side that's going to receive the joint preparation. Okay, so I'm going to go ahead and bust that out, and then you'd still have your melt through symbol, root opening, as well as your included angle. So far these have been open roots, so let's talk about something with backing. Okay, we've done this a couple of times before on previous episodes. Let's talk about our standard, everyday D11 BU2A joint configuration. Okay, a lot of you guys are familiar with this. Okay, standard weld with backing. We got some 3/8 plates here. Now, what's this welding symbol going to look like? Now, because both pieces are getting prepared or prepped, it doesn't matter. I don't have to put a break in the arrow. Okay, here's my bevel, right? Here's my double V groove. And my backing bar is going to go on the top. Remember, the backing bar is on the other side, so where's this going to occur? On the other side. The V is going to go right here on the arrow side because it's on the bottom half. Okay, we'll go with a 3/16 root opening and a 45-degree bevel. Notice again, there's no length or dimensions over here, so that preparation is going to extend all the way through that. We'll do a partial joint penetration here in a second, but for complete joint penetration, it's not going to give me a depth or any other dimensions. Okay, so we have a 3/16 root opening. That's what we have in here. And then this included angle right here is going to be 45 degrees. Okay. Now let's say that this backing bar had to be removed after the weld was done. Okay. They would put an R inside that backing. If there's no R inside that backing, you're going to leave it on. Okay. It's going to go into construction. That's the end product, right? So you don't have to worry about it. If there's not an R in there, your work's done once this is welded out and it's inspected. Now it doesn't mean just because the position that this stuff is in, don't get confused and think, oh, well, everything's in the flat position. Because these welding symbols don't tell you what position. Okay, I could go in here and say it has to be welded in 3G. But for the most part in production, you're always going to weld everything in position anyway. So if I can get to this joint and weld it flat, that's what I'm going to do because I don't want to go to work and show off how great a welder I am going vertical and overhead. I'm going to do what's fastest for the company, what's most cost effective, and that would be the flat position. Once you get into construction, you're out in the field, you don't have the option, right? You can't turn the building on its side, so you can weld it flat. You have to learn to weld out of position. So this could be, vertical, overhead, could be at a 45-degree angle, whatever the case may be. You're going to have to refer back to the prints and see exactly where this material is to be located. But this is how we would prep the material that we're going to go ahead and weld on. All right, so what's all this crap up here? Let's go ahead and discuss it. Let's say I have some 1-inch plate here. I know I'm doing a single V groove because that's the weld symbol that I have right here, right? Right here is my depth of preparation, okay? And this is the depth that my weld's going to be, or the weld size. So I have 1-inch plate. I'm only going to do 5/8 of preparation. So that means that I'm going to come up to about the 3/8 mark, somewhere in there, and I'm going to bevel this back 22.5 degrees. Okay, how do I know it's 22.5 degrees? Because I need a 45-degree included angle. All right, so now I have my 22.5 degree bevel on here for a 45-degree included angle. Let's go ahead and put an 1/8 inch root opening in here. because we came up that 3/8 of an inch, that leaves us with the 5/8 depth of preparation. Okay. All right. So I have 5/8 depth of joint preparation. Because we came down 5/8, that leaves me with 3/8 of a land or root face, depending on old school, new school, whether you want to get technical about it. Okay, that's the opening that I have here. And now my weld is, the depth of my weld is only going to go down 3/4 of an inch. That doesn't count what's on top. Okay, I'm penetrating in here 3/4 of an inch. So I'm going to have 3/4 of weld placement in here. So that tells me I'm going to penetrate an 1/8 inch additional past my preparation. And the back side of this, I'm not going to touch it. I'm just going to leave it completely open because of what is going on here in the notes section. It's partial joint penetration. Okay, so I don't want melt through. I don't want any root reinforcement on the backhand side of this. It tells me it's partial joint penetration, so I know that I'm not supposed to exceed the back side of that plate. My weld should only go down 1/8 of an inch here, which leaves me about a 1/4 inch depth in this area right here. Okay, that's pretty much that symbol. So when you're breaking these down, once again, just start from the left-hand side and read to the right. This tells me I have 5/8 depth of preparation, 3/4 penetration, 1/8 inch root opening, 45-degree included angle, and we're doing a partial joint penetration. Okay, so that's pretty much partial joint penetration in a nutshell. All right, so let's go ahead and check out some different instances with single V and double V joint preparation. So we know that this one right here, what do we have? A broken arrow, which leads me to the conclusion that this side that it's pointing to is going to receive the joint preparation. Where's my symbol? My weld symbol, right? It's on the bottom side, so it's on arrow side, so right to where that arrow is pointing. So this weld joint would look just like this. And then we would fill that in with weld metal. And if there was a melt through, that's how much we would melt through on the back end or apply weld reinforcement there. What do we do over here? It's pointing to this top piece, but which side's getting the joint preparation? Other side, right? Because the weld symbol is on top, I have to put that on the other side. So in this case, this side right here would receive the preparation. And then the weld would look something like that. You just fill that in. Now over here, we have a double V. The arrow's not pointing to either one of the joints. I've got one on top and bottom, so what would I do in this situation? Both pieces are going to receive the preparation. Okay, and the weld is going to look something similar to this. Let's take it one step further. Okay, we have this set up right here. Let's say we have, again, we have some 1-inch plate. And I want to have 1/2 inch preparation depth, and I want 5/8 of weld penetration in there. So I'm going to prep these down, and let's do 60 degrees. No root opening. Okay, we have 0 root opening. They're going to touch. So essentially, I'm going to prep both of these 1/2 inch, and right in this area, they're going to penetrate. One weld's going to penetrate the other 1/8 of an inch because I have a 5/8 weld depth on both sides. This first weld right here, whichever weld you're going to do first, is going to penetrate 1/8 inch into this opening, and then when I fill this side in, we're going to go through that and we're going to penetrate into that opening. So I have an 1/8 inch overlap on the inside of that weld nugget. That's pretty much what you would do in that situation. Okay, and then obviously my included opening is going to be 60 degrees. So each plate will be beveled 30 degrees, right? Let's move on. All right, now let's move up into something a little bit more difficult. Okay, this looks very complicated, but it's not. We just break it down one step at a time. So whenever we're working with a welding symbol like this, whether it's going up this way or down this way, you're always going to work from the arrow back. Okay, this is like a little recipe. So this is going to be our first step in the process, second step in the process, third step, fourth step, et cetera, so on and so forth, right? All right, so the first thing we're going to do is this step right here, after the joint preparation, obviously. We're going to go ahead and prep this 30 degree included angle, 1/8 inch opening. So let's go ahead, we've got our piece prepped. We have a 30 degree included angle in here. And we have an 1/8 inch opening down here. Once everything's prepped correctly, the sequence of welding is going to go like this. We have this symbol right here, it's a backing weld. Okay, so this symbol right here represents a back weld and a backing weld. Okay, confusing, yes I know. So what's the difference other than backing has ing at the end of the weld? Okay, a backing weld is going to go in first. A back weld will come in second. So if it was a back weld, we would actually make our groove weld first, and then we would come back, grind out that area, and go ahead and put that back weld in there. But since backing weld is first here, we're going to go ahead and put this backing weld in right in this area. Okay. Next thing we're going to do is we're going to fill this groove weld in. So you'll put all your passes in here. You'll fill this in completely, right? Flush to 1/8 of an inch. On to step number 3. Well, what's this guy? I have no idea what that is, right? Penetrant testing. That means that before you move on to stage 4, or the 4th step, the engineer wants this specific piece to be die penetrant tested. So that's when you get to call the CWI over there if he's not on hand and say, hey, I'm ready for you. You need to come in here and spray your Contesco die penetrant test in here. Make sure I don't have any cracks before I move on to my 4th and final step. What's that going to be? A 1/2 inch fillet weld. Okay, this is a pretty common connection, especially if you get into structural steel where you got big heavy beams. You'll put a groove weld in there, and then you'll cover that whole thing up with a fillet weld. It looks very intimidating, but it's not. Just break it down one section at a time. If you try to look at it all at one section, you're going to get overwhelmed, right? It's like eating an elephant. How do you eat an elephant? One bite at a time. First, second, third, fourth. Boom, you're done, right? And typically, this stuff's already going to be prepped for you before you get it up in the air, especially if you're doing structural. The guys downstairs, they're going to cut it, or the people in the shop, they're going to set all your joints and your configurations for you before it even gets on site. But you should know what you're looking at, right? Let's go ahead. We'll move into some other groove welds. All right, so let's go ahead and talk about a U-groove real quick. These are fairly uncommon. I mean, just in my line of work, I've never seen it doing structural, but we should cover it. All right, so we have a U-groove here. So we have some material, and now which side is all of our information on? It's on the other side, so that's actually going to occur down here. So our preparation is going to be here, but remember, 1/4 inch is going to be the depth of preparation. So let's call this 1/4 inch. Okay, so we're going to go ahead up to that mark. Get rid of this. Our included angle, 20 degrees. And then our depth of weld is actually going to be 3/8. So that's going to penetrate about an 1/8 inch pass. Now these are typically machined. I've seen Travis Fields do this in another video where he did gas tungsten arc welding on a piece of pipe. And I believe the edges were routed. So that's another avenue you could do this with. But most of the time it's going to be machined. You could probably get this with a grinding wheel and a carbon arc cutter if you had to, or plasma cutting. You could use a plasma arc gouging system and then clean that back up and then just kind of verify your dimensions and do it that way. So that's another way of doing it if you had to do it on steel. But I mean, that's pretty much the U-groove. They're very simple, very similar to a V-groove. We're just changing the profile of that preparation in there. So let's go ahead. We're going to work on the flare grooves next. All right, so here we have a couple of different flare V-groove welds. For instance, this right here, so if we had 2 pieces of box tubing or HSS, hollow structural steel, square tube, whatever the case may be, it's telling us right here that we have 3/8 depths of penetration. Well, this is a naturally occurring joint preparation because obviously when you put these 2 members together, you're going to have 3/8 depth. So that's going to be spec'd out on the type of material that they're going to provide for you, whether it's 6x6 or 4x4, whatever the thickness of the material. It's going to have a natural occurring radius on that side. The engineer should account for that. What we're more concerned with is our depth of penetration. So we want to make sure that we penetrate into there 5/8 of an inch. So you're going to go 1/8 inch past, screwed that up. You're going to want to go 1/8 inch past, where those 2 pieces meet hard up. So you're going to go 1/8 past that 3/8 mark. So the depth should be about 3/8 there. We get into single flare V-groove weld. Notice our weld symbol is on one side of the welding symbol. So where's that pointing at? Or where's that located at? It's on the other side, right? So where are we going to make the weld on this piece? Okay, this side right here is the arrow side. So we're going to go over to the other side and make that weld. Okay, and typically there's going to be some sort of dimensions in there for you. That way you can make sure you've got the appropriate size weld in that area. Moving on, we'll go to the single flare bevel groove weld. Okay, this one seems looks a little complicated, but it's not. All this is saying is, again, depth of penetration is already taken care of because this 3/8. So 3/8 is basically the radius of this material, so the diameter would be 3/4, which is going to give us a nice little 3/8 bevel in here, and it's only asking for a 1/4 inch weld in that area. So we only have to penetrate about a 1/4 inch into that area. Okay, this flare bevel down here looks complicated, but it's not. Let's break it down. What's the flag mean again? Right, we're going to make that weld in the field. Okay, this isn't going to occur in the shop. We're going to do this at the place, the final place of installation. So let's go ahead and start with arrow side. So on the arrow side, right, is the bottom. Arrow is pointing right here. So we're going to put in our fillet weld. Okay, now it's telling us we need to fill in the flare bevel, other side. So that tells me right here I need to fill this in with that groove weld. And then I'm going to go ahead and put a fillet weld in addition, right? Because these are chained off from one another. So here's my first symbol for my flare bevel, and then I have a fillet weld that's going to go right over top of that. That's another way, instead of them chaining them out, steps 1, 2, and 3, they can also be stacked upon one another. And then this side right here, that's just our regular fillet weld. We're going to put that right in here, and we'll just say that's 3/8. These aren't meant to be used in construction. I mean, these drawings here, engineers are going to consult with them, so I don't recommend going out and drawing your own welding symbols and, you know, putting them into action without getting them certified by an engineer. This is just strictly for educational purpose. All right, guys, that's it for this week's episode, but wait, there's more. So we did a homework assignment in the last video. We're going to do the same thing this time. Use hashtag WeilerWednesday. Take a picture of your last groove weld, write the correct welding symbol for it, and post it on Instagram using hashtag WeilerWednesday. We're going to pick 3 winners to receive a Weiler dually. Okay, this isn't your single stack Dodge dually there, Kyle. So what it is a knotted wire wheel with a nut on each side. So when you start running it one direction and it starts to wear in, you can actually flip it over and use it the opposite direction. Bonus, it's got a nut on both sides so you can get a hold of it with a wrench, because you know how wire wheels like to bind up on your grinder? You'll be able to get these off no problem without tearing up your leather gloves. So hope you guys enjoyed the video. Make sure to sign up for the contest. Hashtag WeilerWednesday on Instagram. Until next time, make every weld better than your last.